So let's talk about something called the enthalpy of solution, or more simply the heat of solution. This is the amount of heat that's either absorbed or released, either one, when you dissolve 1 mole of a substance in water. So when you dissolve some ionic solids in water, the solution becomes hot. We say that it's exothermic. But when you dissolve other ionic solids in water, it becomes cold, and it's endothermic. So let's see why this happens and why there's different things that happen. This picture is an overview of the whole process of, say, dissolving sodium chloride. Sodium chloride is in a crystal lattice, right? A bunch of sodium ions and chloride ions, and they're attracted to each other by ionic bonds. Okay, so the first thing you have to do is somehow pull these ions out of solution. So these water molecules come in and they pull these ions out into the solution. Okay, they come in and they pull the ions out into solution. So they're basically helping to break these ionic bonds. At the same time, the water molecules need to spread out from each other to make room for the ions, and that takes a little bit of energy. And then the water molecules come and surround the ions, okay, and this releases energy. So first of all, we have to add energy to separate the ions. We have to add energy to separate the water molecules, but then it releases energy due to the attraction between the water molecules and the ions. So there's 3 different processes that are going on here. So the first thing, again, you have to separate your ions from each other, break ionic bonds. This is called a lattice energy, and it's always positive. So it's just the water molecules coming in and pulling the ions apart. That's the first step. Second step is all of these water molecules have to get away from each other to make some room for ions to go. They're breaking relatively weak intermolecular attractions called hydrogen bonds. We'll learn about those a little bit later, but that's what holds water molecules kind of together. So again, you have to add energy to do this, but usually a lot less than to break an ionic bond. So the first step adds a lot of energy. The second step, you're adding a little bit of energy. But now we're going to get some energy back, okay? It makes sense that if I have to add energy to break a bond, if I put things together, I should be releasing energy. So when the water molecules surround the cations and anions, they release an energy called the solvation energy, which is always negative. So now when they come in and surround them, now we're getting energy back. So the heat of solution equals the lattice energy, which is always positive, plus the energy to break the hydrogen bonds, which is always positive, plus the solvation energy, which is always negative. So if these 2 things are bigger than solvation energy, then you have a heat of solution that's positive, and you have an endothermic reaction, and your solution gets cold. But if this is bigger than those 2 things, okay, then your heat of solution is negative, and you have an exothermic reaction, and your solution gets hot. Now, we're not actually going to calculate which are bigger. We're just going to look at reactions or processes and say, oh, that got hot. It's exothermic. Solvation energy must be bigger. Or, oh, that got cold. Therefore, lattice energy in breaking hydrogen bonds is bigger. Okay? Let's try an actual problem. What would a mathematical problem look like here? When I dissolve 4 grams of NaOH in 100 grams of water, the temperature increases by 23.4 degrees Celsius. What's the heat of solution for NaOH? So we're talking about calorimetry here. The heat is minus mc delta T. Okay, now the thing changing temperature is the water. So minus the mass of the water, specific heat capacity of water, times the change in temperature of the water. Okay? And if you do that, you get minus 19,037 joules, or negative 19.0 kilojoules. Okay? Because remember, heat of reaction is going to be in kilojoules per mole of NaOH. So we've got the kilojoules, now we need the per mole. So we take the 4 grams of NaOH. Okay, we're going to change grams to moles. Sodium hydroxide weighs 40, so you got 0.1 mole. Okay, so your heat of solution now is kilojoules per mole. So it's negative 19.0 kilojoules, 0.1 mole. So negative 190 kilojoules per mole. Okay, so you release 190 kilojoules every time you dissolve 1 mole of sodium hydroxide.